All right, so for chemical reactions, we are recording, yes? I already told you the tips for combustion reaction. Can somebody, if I was going to do propane, C3H8, if I wanted to show the combustion of propane, and I will show you kind of the difference in the two here in a second. Who can walk me through the combustion of a hydrocarbon? That is a compound that contains only carbon and hydrogen. A hydrocarbon. By the way, with our rules for naming molecular substances, if you didn't know the name of this was propane, what would you name it using your rules for molecular substances?
Tetracarbon, I don't know.
It wouldn't be tetracarbon.
I don't.
It's three.
Triple dihydrogen.
Tricarbon.
Tricarbon.
Tricarbon,
Octahydride.
Octahydride.
But we do not say tricarbon octahydride if we know a common name, because remember, if you know a common name, you must use it. This is propane. So if you haven't added this to your notebook, that's going to be on you, not me. This is propane. And yes, this is the gas that you have on your grills.
Oh, that's right. That's a protein.
So, what is the rules for combustion of a hydrocarbon that I gave you yesterday? Jack, start us off.
Well, you can first start.
First of all, what is combustion?
Oxygen.
Oxygen molecule. Good. What does combustion always make?
Water.
In the reaction with a hydrocarbon. Water and
CO2.
carbon dioxide.
Is it supposed to smell just a little bit?
You'll be fine. It should not be giving off a gas or an odor. If it smells a little bit over there, you don't blame the chemicals.
What do you blame them?
Oh.
Then, what do you do next when it comes to combustion of a hydrocarbon?
Coefficient.
Yeah, but where do we start? I gave you a rule.
HO2 water.
Yeah, we start with water. Always start with water, and look how you can balance these hydrogens. This is an 8. I need what to balance it off? A 4. Is a 4 an odd number? No, it's an even number. So this is going to fall out eventually. We don't need to stop and go back and double the hydrocarbon, which is great. So I start with water on a hydrocarbon combustion, and I can see, hey, that's an even number. This will fall out. I just need to balance my carbons. So I need a 3 here. And now I can add up all of those oxygens. It will be a factor of 2, and all will be well. 4 times 1 is 4. 3 times 2 is 6. 4 and 6 is 10. What do I put in front of oxygen? A 5 coefficient will do the trick. That is the combustion of propane. But if you look at butane, butane torches are a little bit different. That's a 4-carbon sugar. And as you can see, it has a different formula. The combustion of a hydrocarbon means you're always reacting this with what molecule? Combustions are reactions with oxygen. And since it's a hydrocarbon, we do know the two products. The products are water and carbon dioxide. Awesome. Now again, you don't change it. Always start with your water molecule. Trying to balance those hydrogens. Yeah, I can see I put a 5 here. Is 5 an odd number?
Yeah.
Yes, so this is not going to fall out. This won't work. You'll always end up with an odd number of oxygens, and there's nothing you can put in front of the coefficient 2 to make that an even number. So you stop.
Double
Wait a
it.
minute.
We stop, erase that. It's not going to work. Double our hydrocarbon. And now everything will fall out. Now I have 20 hydrogens. I need a 10 here. I now have 8 carbons. What do I put in front of CO2? 10, 8. And now I have to total up all of those oxygens. I have 10 here and 16 here. 10 and 16 is a total of
26.
And what do I need to put in front of O2? A 13 will do the trick. And these will fall out every time. So in other words, if you're following along, if you're taking notes, then it doesn't matter which hydrocarbon I give you, you should be able to balance those pretty darn quick as long as you don't make a mathematical error,
Which never happens.
which never happens. Now let's look at our demonstration for today. Preston.
So could you hypothetically make a cocaine bomb? That was
That's
Rocky's question, you made me ask it.
Rocky. I don't understand you. You're in love, but
We got
not
on video
understood.
too.
You didn't answer the
It's a
question.
valid question.
What's the
I'm sure you could make a bomb, anything.
So like.
This is on video.
Everyone's super
We
hot.
have to cut this whole part out. Yeah, we're gonna have to cut this part out. Cut this part out.
What is this question?
You know how to edit videos? No, leave
Yes.
leave it in for Rocky's
Nowadays, you never
parents.
know.
So we don't have to go down those roads, but it's not hypothetical. That's poisoning using an aerosol. Okay. So yeah, you can.
He's trying to kill people.
We should stop it.
All right,
Illegal is a loose.
Jack.
Or pause it.
Are we gonna mix some water, copper, and silver nitrate?
Yeah, we're gonna do this now. So copper wire. What is the formula for copper?
See.
Cu. Remember, there's only 7 molecules or elements that are diatomic on Earth. Copper is just Cu, and I mixed it with silver nitrate. This is the vital thing. Remember, whenever you have an ionic bond, you have to use the crisscross method. If you look on your periodic table, which you will have, you will see that silver only has 1 oxidation state, and that's a +1. Nitrate you have memorized.
Yes.
NO3 also -1. And as you can see, 1-to-1 ratio means that this formula is going to be what?
Simple.
No.
Ag
It's never simple.
What?
NO3.
Wait.
Where?
All right. You must crisscross using this method for every ionic compound. It is the #1 mistake students make. They just write down the compound without crisscrossing. They don't have the right subscripts. If you don't have the right, if the equation is not written correctly, you cannot balance the chemical equation. I don't know what else to say. All right, this does fit one of our molds of types of reactions that you studied last night. Who can tell me what type of reaction this is? Jack,
First, I want to ask, what about water?
what about water?
What about?
Could you make a bomb out of
Hydrogen.
Remember yesterday,
Those already exist.
Okay. Single replacement. For real.
yesterday we used these, when you have something in solution, we can label it AQ for aqueous.
Okay. Never
So
mind.
water is not going to be a part of this reaction.
So single replacement.
This is a single replacement. And what is the rules for single replacement according to your notebook? It was in big bold letters. The metal will always kick out the metal, or if it's a single replacement with a non-metal, which I'll show you here in a second, and the non-metal will always kick out the non-metal. So in other words, the Cu will give Ag the boot, and what we should see in this reaction is silver being produced and a copper salt. Now I will tell you what this copper salt is. It's copper 2 nitrate, Cu, Roman numeral 2 nitrate.
Looks more like
No, my pen's dying.
And so what is the formula for copper 2 nitrate? What's the charge on Cu Roman numeral 2?
Oh, negative.
It is 2. The Roman numeral is the charge. And nitrate, of course, you already know, is NO3. It's in the -1. 1 goes here. A 2 will go outside of parentheses. Cu, NO3. All right. So, here's what we know from the demonstration we started today. Copper is a solid that has this bronze color.
Why does it have a bronze color?
It just is. It's its physical property. Silver nitrate was a perfectly, beautifully clear liquid. Now that's when it was dissolved, we all know that it was a white salt. It looked very much like table salt. You could easily mistakenly eat it, and then you would be sick to your stomach.
April Fool.
And or want to die. Alright, so bronze, nice clear liquid, looked exactly like water. Now, you should be able to predict the color of silver. Silver has this very shiny or very light gray color. Almost whitish gray. Who has still sterling silver on right now? That's aluminum. It kind of looks like aluminum.
Same thing.
I'm a girl.
Sir, right here, right here.
Wait, this is so
I got no diamond grill.
How about we just say silver is a silver color?
What?
Yay.
But wait, if it isn't a silver
Wait,
color,
would
then
you
what's
see like
silver
gold
color?
or
Should have brought my lead belt.
Wait, what about
That's a weird one. Depends on the day with that one.
Now, copper nitrate, what we find out with copper salts is they're often greenish and blue in color. And so we can predict, if this is the case, that this should end up with some type of blue tint. If this reaction does actually take place, which I believe is already taking place.
It's gonna like oxidize like in the water or something.
Crystallizing.
So, again, we'll let this go definitely overnight, and you can check it out as you move on. It is so pretty.
What?
Wait, can I go look at it? It's so beautiful.
As long as you don't go up and bump the cabinet, go take a peek and you can report to your class.
I'm on camera duty, man.
It's crystallizing.
We are on camera duty. Go then.
It actually looks like silver.
It's on video. Go.
Because guess what it actually is? It actually is silver.
Is this transfiguration class?
Wait, can you sell that?
Whoa, you can sell that.
Wait.
You could turn pennies into like pieces of silver. And
They stopped producing pennies. Yeah,
It
pennies
is
are
like
circulation.
crystal. Crystal.
Well, one, silver nitrate, that's not the best way to make silver, but yes, you are making silver.
Fine, I'll go with that.
You're not making silver, it's there.
You heard it here first.
Now, pennies, by the way, only have a very little copper on them nowadays. Copper pennies stopped somewhere in the 1960s. They now have a very slight, in fact, we'll do this year too.
Wait, didn't they stop making?
We can just nip a penny with a wire cutter, and then we can dip it in some hydrochloric acid. The hydrochloric acid, as you already know, reacts with zinc,
Oh yeah.
and because that's how we made our hydrogen gas.
That's when you think.
And then what I can then take is give you the penny that's left over. It doesn't react with copper, and all it is this little thin thing of copper. Pretty interesting. All right, so let's look at those very quickly. We can look at both of those. One, I want you to look at this one. This is, let's go with bromine. What is the formula for bromine on Earth? Incorrect. What is it, Taylor?
Oh, yes.
It is Br2 because it's one of your seven diatomic molecules. This is going to react with sodium iodide, which is a salt. How do I know it's that formula? Because Na is in group 1. That would be a positive one. You want to lose that one electron. Iodine is a halogen, group 17. So how many does it need? That is a 1-to-1 ratio. Notice that you have to do your crisscrosses to make sure you have the appropriate formula. This does fit one of our types of reactions. It is single replacement again. Notice the non-metal, though, will not replace a metal. The non-metal will replace the non-metal. Na will react with Br. Let's make sure we have that formula correct. Br is a halogen. It's still 1-to-1.
It's all about the formulas.
It is all about the formulas.
What about
And
the color?
iodine. What is the formula for iodine on planet Earth?
I don't know.
I2.
It is I2
But it's
because it is also a diatomic molecule. Now, this one does need to be balanced. Well, the last one needed to be balanced. We didn't balance it.
Why don't we do that?
I don't know why we didn't do it. We would need to put a 2 in front of the silver nitrate and a 2 in front of the silver. But this one just needs a 2 here and a 2 here to balance. It is not that difficult to balance, getting the number of atoms equal on both sides. Good, that's a single replacement metal replacing non-metal. And the last one I want to show you that will help you is when hydrogen acts like a metal. Remember, hydrogen, because it's a very weird little atom with only 1 electron and 1 proton, it does, and this is the reaction I used the other day, it does act like a metal when it's in the form of an acid. How will you know that hydrogen is in the form of an acid? Well, you'll see that H come first, like you would put a positive ion. So that's when it's going to be acidic in its character most of the time. Of course, plenty of elements, I'm saying, sorry, compounds have hydrogen in them, but when you see hydrogen come first, that can act very much like an ionic bond. And so in this case, metal has to kick out metal. Metal, there is no metal. Well, hydrogen's acting like a what?
Metal.
It's acting like a metal when it's in an acid. So when you see hydrogen in an acid, it's acting like a metal. And so this will make zinc chloride. Who can tell me the formula for zinc chloride? And it will make hydrogen gas. That's what we collected.
Oh my gosh.
That's not correct.
Oh.
If you look on your periodic tables, no one has periodic tables out. You should have your periodic table out.
Bradley.
You will see
I got
that
this.
Zn is a +2 ion, always. Cl being a halogen is always -1. So what is the appropriate formula for zinc chloride?
Wait, no.
It is
Zinc.
3.
I like this one.
ZnCl2.
ZnCl2.
It's not.
Notice the crisscross has to be done for all ionic compounds. Now we can balance this chemical equation with a simple 2 in front of the hydrochloric acid.
Hey.
All right, that's very good. These are the things I wanted to do before I let you loose on some worksheets.
Oh.
What's that groan?
Yikes. Whoa. What did you say?